Welcome to Spring LIB.
Okay, so we're doing chapter 23, problem 79. So it says a lightning flash transfers 4 coulombs of charge and 4.8 megajoules of energy to the Earth. Part A says between what potential difference did it travel? So we know that the change in potential energy is given by the charge times the change in potential difference. So we can rearrange this and solve for the potential difference as the change in energy over charge. So this becomes 4.8 megajoules divided by 4 coulombs. And that comes out to being 1.2 megavolts. And this is our potential difference. Cool. Part B, the energy. Oh wait, what is it asking? How much water could this energy boil starting from room temperature? Okay. So the energy used to raise the temperature of water and boil it is given by the energy as mc delta T plus m times the latent heat. Okay, so we already know the latent heat. We can look that up. We can assume that we're starting at T initial of 20 degrees. Boiling temperature then, T final, is 100 degrees. So our Q becomes, how much water do we have? That's what we want to find out, right? So let's actually solve for M. So M equals Q over C delta T plus L. So that is now 1.2, oops, not 1.2 Q. So it's 4.8 megajoules all over. C for water is 4186 joules per kilogram Celsius times our delta T, which is 80 degrees. And then we add on the latent heat, which is 22.6 times 10 to the 5 joules per kilogram. Cool. So it's actually pretty simple, and this comes out to being 1.8 kilograms of water. Cool.